Hello, my name is Rachel Boy, and I'll be presenting a proposal for my master's project. The title of this project is Cooling Technology Limitation of a High Heat Flux Chip Changing with Altitude. This project was first brought up by Dr. Okamoto and Dr. Kabani of San Jose State Mechanical Engineering Department. The background and motivation of this project comes from the fact that many electronics these days require some kind of cooling and airflow to operate without difficulty. And it was interesting to see what different circumstances could affect the effectivity of cooling. When researching about portable cooling devices, companies admitted in a statement that the cooling technologies have not been tested for elevations higher than 2,500 feet. As of now, air and liquid cooling methods are the most common methods for cooling. So those will be tested to cool heat sinks up to 6,000 feet above sea level. The main objective is to define the limits of when air cooling is ineffective and liquid cooling is needed to moderate the temperature limits of an electronic device. This means that when air cooling is not able to cool the heatsink, liquid cooling methods will be used, and the optimal results would be which method works the best. Elevation levels will be a variable of importance, and for each cooling technology, there will be testing at 5 different elevations. The final results of determining the most efficient cooling method will be from the electronics resistance to heat. The major deliverables include Excel sheets of theoretical calculations and graphs and plots. The graphs would consist of pressure drop versus altitude and microchannel resistance of heat to altitude, and the plots would be of the pressure drops of all cooling methods at specific altitudes, and another one with the microchannel resistance to heat of all cooling methods at specific altitudes. There will also be a SolidWorks 3D model of a microchannel, and then that microchannel 3D model would be inputted into ANSYS for the CFD analysis to confirm the theoretical calculations in the Excel spreadsheet. The evaluation metrics include minimum allowable pressure drop across the channel and thermal resistance of the microchannel with different cooling methods. For both evaluation metrics, there will be air cooling and liquid cooling simulations at 0, 1,500, 3,000, 4,500, and 6,000 feet. For methodology, as I briefly went over in the deliverables, there will be a 3D model made in SolidWorks that will be a default microchannel for all simulations in ANSYS. For the ANSYS part, the microchannel will be used for all simulations. There will be 5 elevations, and for each elevation there will be different properties like water and air for which will be determined. At each elevation there will be air cooling with a fan and liquid cooling methods. That includes jet impingement, porous media, and phase flow. So in total there will be 20 simulation results. Here's the Gantt chart, which starts February 5th of 2021 till the end of the semester. Starting is the process of a final submission of the literature review that will include further research and professional revision. The 3D model will be created with known material and dimension properties by mid-May. Once everything is ready for calculations, an Excel spreadsheet will work for the theoretical calculations as well as the graph and plots. In April, CFD analysis will be conducted. If all goes well, the theoretical results will determine the optimal cooling method in May. Throughout the semester, there will be bi-weekly meetings to discuss the process and difficulties of this project with the advisors. A challenge that I will come across is the inexperience of ANSYS, and so hopefully one of the advisors, Dr. Thurlow, will help me through the process of ANSYS. For the preliminary work, I created a model in SOLIDWORKS. The discussed size of the whole system would be the size of a gaming console. With previous experience of designing an effective heatsink, the model came out to be 110 by 110 by 54 with 50 channels and is compatible with all types of cooling methods. Here's the most important formula of the calculations, which is the resistance of heat. For this project, I would mostly use a computer that has Microsoft Excel, SolidWorks, and ANSYS. There are many electronic devices used by people, especially because of quarantine and the gaming lifestyle. It is important to know which cooling method can up the electronics quality as well as determine